Hey everyone, so the problem I'm doing is from section 10.8, it's number 5. It's f of x is equal to the square root of x at a equals 64. It's the find the Taylor order 0, 1, 2, and 3 generated by f at a. So, you know you're going to need this formula, first off, right? I think we all know that by now. It looks cool, kind of like it's kind of easy to remember. Okay, the first thing is at 0, well, that's pretty easy. You're just putting 64 in here, which is 8. I've gone ahead and actually written the entire answer just so everyone can see how similar it looks, or how MyMathLab wants it. Okay, so at p sub 0 equal to 8. 64 in there, 8, alright, perfect. That's the first part here. Continuing on, if you just find the derivative, right, because now we need to kind of move on, you can kind of say here is at 0, here is at 1, here's at 2, and there's 3, and so on. We've got our 0 and our P1, you can see it here, is 8 plus 16 times x minus 64. And there's P2, and so on. Now, the one tricky part for me, I know this is kind of elementary for everyone coming from Calc 1, but the derivative of the square root of x looks like that. I remember getting that far. I don't quite remember doing it twice or even 3 times. So that was kind of a tricky part here. But okay, you go ahead and differentiate it the first time, then you plug 8 in there. To let's see, where was I? It's 1 over 16, right? Well, okay, that makes sense. I'm sorry, 64. Bring 64 in there, which would be 8 times 2, 16. So we've got our P1 again, and then you can plug it here. And that's how MyMathLab was doing it, kind of one by one by one, but I just wanted to do the whole thing out so you can kind of see. Here's 0, 1, 2, and 3, and so forth. So okay, finding the double prime of square root of x looks like this. I mean, it makes sense, I just don't really remember ever doing it before now. And I guess everyone should know that 2 factorial is 2. So when you're plugging your values into this equation here, so you're putting in 64, our a value, into here, times 4, but also dividing by 2, or multiplying by 2, I'm sorry, to find this value here. And I chose this question as an example because of this huge number here. It's like 500,000. I think even another question has like a equals maybe twice that, I'm not sure. And it goes to like 1 over a million something, and it was pretty funny. Okay, so just keep going on. You've got f, was that triple prime, I guess? Yeah, so that makes sense too. I guess this might be easy for a lot of people, but I've just never done this so many times with the square root of x. And yes, 3 factorial is 6, so that's how you kind of get to this gigantic number. Once you're putting in, you have this third derivative here, and then you put in 64. And you still have 3 on top, so once you kind of simplify that, you're going to have the 6 underneath all of that because of the 3 factorial here. So yeah, it's a long question. It's like 4 parts or so, but it's kind of piecemeal. Once you have the very first one, you pop that in. It's okay, find it at 1, you go ahead and put it in, and you've got this giant equation here in front of you the whole way to kind of do it piece by piece by piece. It wasn't super clear. I didn't work out like every little step because you're basically just putting in the values you find directly into the equation. And then there's just really algebra. But yeah, it was fun. Giant numbers, or technically this is a very small value, right? But biggest numbers I've seen yet in my math lab. So I hope everyone's enjoying section 10.8. I kind of am. I like this week's homework and stuff. All right, everyone have a good spring break. Enjoy yourself. Maybe study some calculus to feel more confident about the upcoming quiz, right? All right, see you next time.